everyone, and welcome back to Sum Things Up. So today we're going to do trig derivatives, exponential derivatives, and logarithmic derivatives. And I was debating if I wanted to do this video or not, but I guess I am, just in case anyone's struggling with this or wants to know. But the reason being is just because this is all really memorization. Any more like complex problems are going to have to deal with like knowing how to use the chain rule, knowing how to use the product rule. This is really just memorizing like what the derivative of each of these like simple functions is, but either way, let's get into it. So starting off with trig derivatives, I'm going to show you the ways that my calc teacher taught me how to memorize them, and then I'll just give you what they are. Okay, so for cosecant and sine, the way to remember it is it goes sine of x to cosine of x to negative sine of x to negative cosine of x. So say you were trying to find the derivative of sine of x, you would just do the one below it. If you're trying to find the derivative of negative sine of x, it's the one below it. So it's always just going to be the one below it. It goes in a cycle. So below this one is just going to be sine of x again, and then repeating. So that's helpful to keep track of the sign change, but other than that, it's not really that difficult to memorize. Okay, so then for tangent and secant, so tangent and secant go together. That's one thing to memorize. So the way to memorize this is always going to be tangent of x. Now, like, I'm going to do these separating it, but secant of x separating, okay, secant of x. So say you're trying to find the derivative of tangent of x, it's going to be these two, which is just secant. Ooh, why did I write it like that? Secant squared of x. Say you're trying to find the derivative of secant squared of x, it's going to be these two multiplied. Simple. That looks like so weird, but, and then it's going to be the same exact thing for cosecant and cotangent, so it's going to be cotangent of x, and this is going to be negative cosecant of x, and then cosecant of x. So this is easier to keep track of the signs. So if you're trying to find the derivative of negative cosecant, it's these two. Trying to find the derivative of this, it's negative cosecant squared. So it's always the other two. So knowing that, we have sine of x, where's that? Right here. So the derivative is going to be cosine of x. Okay, cosine of x, that's right here. The derivative is going to be negative sine of x. Okay, tangent of x, we know that's right here, so it's going to be secant squared of x. Okay, cosecant, that's right here, but it's not negative, so it's this one. So it's negative cosecant x times cotangent x. Secant is right here, so we're going to have secant x times tangent of x, and then cotangent right here, so we have negative cosecant squared of x. Okay, so hopefully that's simple enough. It's just memorization. Okay, so now we have exponential, but to go back to trig for a second, like, I'm just showing you the basics. Like, a question is gonna, if it's gonna be anything different, you're gonna have to utilize chain rule, power rule, anything. So if you have like tangent of 2x squared, like, right, like, you're gonna just have to memorize this. Like, there's no other way of figuring out. And then the rest of the problem, you're gonna have to use chain rule. Like, no, this is the inside function, this is the outside function. So the derivative of this would be secant squared of 2x squared times 4x, because you did chain rule, you did power rule. It's the whole jibble jabble, but this video is not covering that. We're just doing the basic like facts that you have to memorize. Now this is super easy. So for exponential, e to the x, the derivative of e to the x is always just e to the x. It's always the same. So when you have the next problem here, you're gonna have to utilize chain rule. So first you'd have e to the x, and then this is the inside function. So you'd have to times it by the derivative of the inside function, which is just 4. I know, guys, this chocolate, I'm deeming like the study chocolate of all chocolates. It's so freaking good. Okay, so now it gets a little bit more complicated, but it's still like kind of easy. So derivative of 4 to the x, we have, this is just the rule that you have to memorize. It's L equal to ln of 4 times 4 to the x. So that's just what you have to memorize. So then if it switches a little bit, it's just utilizing chain rule. It's nothing really that much different. That's what I was saying. It's like just memorization. But the derivative of the outside function, which is 4 to the x, would be the same thing, because we just did that up there, ln of 4 times 4 to the x. Then you'd have to multiply that by the inside derivative of the inside function, which would be 7. So obviously you can simplify that. I'm not going to. So now we have logarithmic. So this is just, again, you just have to memorize this. So this is equal to 1 over ln of the bottom number here, which would be 5, times the number, the x here, which is 3x. Or if I don't know if this is going to make it simpler or harder, but I think about it like times 1 over 3x. And then you're going to have to times it by the derivative of the inside function, which is 3x. So that'd be times 3 over 3x ln 5. We have this problem. It's just the same thing, but we're doing more chain rule. 1 over ln of 2 times x squared plus 3x. See what I did there, like because it's multiply the bottoms. And then we're going to times this by the inside function, derivative of the inside function, which would be, I'm just going to do a parentheses, 2x plus 3, and then that's it. So obviously, you can simplify this, just put this on the top. But yeah. So now we have the derivative of the ln, which you should know is a natural log, which is just a log of e. Log base e, I mean, whoops. Anyway, so since you know e to the x is always going to be the derivative of e to the x, so it's going to be e to the x, it's kind of the same thing with ln. Or it's just going to be 1 over the x here, so it's going to be 1 over 2x. And then you have to times by the derivative of the inside function, so times 2. That's going to be 2 over x, which is going to be 1 over x. Anyway, and this one's just going to be 1 over this x here, the x of the outside function, 3x squared plus 2 times the derivative of the inside function. This is chain rule, but it's okay. So 6x. Yeah, 6x. And that's all you need to know. Okay, so to sum things up, you just have to memorize the rules of what the derivative of sine of x is, or what the derivative of 4 to the x, the power of x is. But knowing the more complex problems, you're going to have to utilize chain rule, you're going to have to utilize power rule, yada yada.